Okay. Hi guys, my daughter is still sick today, so I'm home with her. Um, the quiz, we'll figure out when we're gonna do that. Maybe we'll do that tomorrow. But I didn't want to get too behind, so I recorded a video for 4 point. I'm recording the video for 4.5. So watch this video and try to do the homework, okay? Um, this is just some more ways to show two triangles are congruent. Over the last few days, we've talked about side, side, side. We've talked about side, angle, side, and we talked about hypotenuse, leg. Um, Now today we're going to add in angle, side, angle. So now we're talking about when you have two angles with the side in between. That's the included side, the side in between. So if you have two angles with the side in between of one triangle congruent to two angles with the side in between of another triangle, then these two triangles are congruent. And if I was going to write a congruence statement, if I named this first triangle ABC, then I would have to name the second triangle the same way. So I'm going from the 2 arc to nothing to the 1 arc. So I would have to go from the 2 arc to nothing to the 1 arc. So it would be D, E, F. Okay, and they are congruent because of angle, side, angle. All right, next one is angle, angle, side. Now this time we have two angles, but do you see how the side is not in between them? This would be the side in between the two angles. We're not given that. So if we were to kind of like follow along, it goes from an angle to the very next angle to the very next side. That's why it's angle, angle, then side. Or I could go side, then angle, then angle. I mean, I could write this as side, angle, angle. That'd be okay. It's the same. It's just backwards. Okay, two angles with the side not in between. If I have that on both triangles, so again, here I've got angle, then to the next angle, then to the next side. If I have that of two triangles, then they're congruent. Okay, wait a second. Going back now to the very first page, we just added on angle, side, angle, and angle, angle, side. So look at those combinations and what's missing. Okay, here's what's missing. Angle, 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 and side, side, angle. Let's add hypotenuse leg up there. Okay, these are all the ones we have so far. Angle, angle, angle's not up there. The reason is because three angles is not enough information to show that two triangles are exactly the same. And let me try to demonstrate that for you, okay? So I've got two triangles here. They both have the same three angles, but angles alone aren't enough because I could blow this shape up and they still have the same angle measurements. Okay, these angles are the same, these angles are the same, these angles are the same, but the sides are not. It's like I blew up the picture, enlarged it. And so these are not congruent because the sides are not the same length. So they're not congruent. Angle, angle, angle is not enough information to show two triangles are congruent. The other one that's not up here is side-side angle. This is also not enough information. I'm going to try to demonstrate that for you. First of all, do you understand the picture that we have a side, goes to the next side, and then to the next available angle? Side, then an angle. The angle's not in between the two sides. Okay, well, this angle is fixed in place, and this side length is fixed in place. They are stuck together. But there's nothing saying that that angle couldn't change and that this side length couldn't change. So here's what could happen. This side right here, I'm going to keep it the same length, but I could turn it and put it like that. So then what I could do is I could take and like ignore this right here. Let's see. Let me try to cover it up. Okay, so just ignore that. Do you see how now I have two different triangles, but with the same given information? So I have the same angle, I have the same side, and this is the same side length. All that's the same, but this angle and this angle are not the same, and this side are not the same. These are not congruent triangles, even though they have the same given information. Same angle, same side length, same side length. It's just that I bent this side in, which changed that little angle and changed this side. Okay, so here's like a corny way of remembering that these two are bad, that they don't show triangle congruence. This one's the easy one. Just look at it backwards. Spell that backwards. See how it's a bad word backwards? Okay, so bad word backwards means no good. Don't use it. And then AAA is, you might ask your parents about this. AAA is an organization that, well, I have it. You pay money like once a year, and so like if your car breaks down on the highway or something, AAA will come out and they'll like change your tire for you or jump your battery for you. So I have it just because I've got little kids, and if I'm all by myself, then if something happens, I can call AAA and they'll come help me. But here's the thing, if you're calling AAA, something bad happened to your car, right? Like your car's broken down. So AAA means something bad is happening, so no good. And side angle backwards spells a bad word, right? So that's also no good. Okay, so let's do a couple examples. Here's some given information. We are given that BD, this side right here, is congruent to side BC. That's a given. Then we're also told that AD is parallel to EC. Parallel, not congruent, parallel. Well, back a couple chapters ago when we had two parallel lines and like a transversal cutting through them, we would talk about things like alternate interior angles being congruent, right? Okay, well look at this picture. That angle and that angle are alternate interior angles, just like I drew on this picture. So they are congruent. Okay, so since those are parallel lines, then angle ADB would be congruent to angle, okay, ADB would be congruent to angle ECB because they are alternate interior angles. Okay, so far in our picture, we have one side of one triangle congruent to one side of another triangle, and one angle congruent to one angle. That's not enough information. Look at these are the ways that we have to show two triangles are congruent. We got to use one of those. Right now we have a side and an angle. So it's probably going to be that one or that one or that one. This is all three sides. We already have an angle, so it's going to be one of those. Okay, can we get another angle? And the answer is yes. Look at this angle right here is congruent to that angle right there because they're vertical angles. I can say angle ABD is congruent to angle EBC because they are vertical angles. Okay, well, now look at the information I have. I have an angle, then a side, then an angle. I have an angle, then a side, then an angle. It looks like I have angle, side, angle. Is that one of our ways to prove triangles are congruent? Yep, there it is, angle, side, angle. So, whoops, so these two triangles are congruent. Triangle ABD is congruent to triangle EBC because of angle, side, angle. Okay? We just had to do a little bit of work. We had to use this piece of information. If they're telling us parallel lines, then we got to get something from that. That's how we got the red angles. They're alternate interior angles. Then we had to figure something else out, and these are vertical angles, so we know they're congruent for sure. Okay? I don't know. I didn't know anything about how long these sides were or how long those sides were. So I can't just go and assume anything about them. I have to find some concrete evidence. Okay? So we got it. We got angle, side, angle. All right, let's do one more real quick. This one, we're given more information, so this will go faster. We're told that angle B is congruent to angle C. Check. We're told that angle D is congruent to angle F. Check. So as of right now, we have two angles, right? So according to our options, two angles, that does not have two angles, this does not have two angles, this one does, and this one does. So it might be angle, side, angle, or angle, angle, side. So let's check. Can we show angle, side, angle? Or can we show angle, angle, side? Well, we haven't looked through all of our givens yet. M is the midpoint of DF. M is the middle of this side length, which means it splits it in half. So then, since M is the midpoint, then we know that DM is congruent to FM. All right, well now which one do I have? I've got angle, then the next angle, then a side. You see how the side is not in between these two angles? This side is not in between, the green side that we highlighted is not in between the two angles. It goes angle, then the next angle, then the next side. So triangle BDM is congruent